Okay guys, so we are kind of in the home stretch of limits. I really hope that by now we're kind of really making sense of how to go about these. Now let's go ahead. This is basically your homework solutions for every problem. Let's go ahead and make sense of it, okay? First things first, I want us to really hammer in, all right? Exponentials, E is just some number. It's just like 2.7. Oh, let me use a different color. That's way too thick. E is just a number like 2.7, all right, raised to the, I guess in this problem it's 2x. I'm just talking about this section here. So when you see E, it's just an exponential function. And remember, exponential functions will always grow faster than any polynomial. So even though this is x to the 99, okay, exponential functions grow way faster. We kind of learned that in algebra 2 and hopefully a little bit in pre-calc, that exponential always grows faster than any other function, all right? And so basically if I plug infinity here, I'm going to get some number that's going to get huge, right? This is going to be pretty big because it's all raised to the 99. Well, because I have exponential, this is going to be more huge. It's going to be way bigger. Therefore, okay, this is going to be, the denominator is bigger than the numerator. And so it's going to approach closer and closer to 0. And that's my answer there. Okay. The next homework problem says, which of the following does the limit as x approaches infinity give you 0? So we basically saying which one gives me a horizontal asymptote of y equals 0, okay? Now I want you to look, when you have x squared and the square root of x, these are inverses of each other, right? If I had x squared divided by the square root of x, all right, and I did the limit as x approaches infinity, well, x squared is going to grow way faster than the square root. So this would just be infinity because the numerator grows way larger. So why do I show this up? Well, the reason I show this up is because, okay, if we have the exponential function y is equal to e to the x, well, the inverse of e to the x is ln of x. These are inverses of each other. So if e to the x grows, if this grows the fastest, I don't even know if I spelled that right. This is going to grow the slowest because it's an inverse. It's the opposite. So over here, well, the limit, okay, the limit as x approaches infinity of this problem up here, well, this is going to grow slow. And this is going to get pretty big because the polynomial is going to get way larger than the inverse, which is way slower. So if the denominator gets way, way, way bigger than the numerator, we're going to get 0. So we know, in fact, this is to be true. Okay. Well, let's look over here at this example problem right over here. I'll do it right here. Well, the limit as x approaches infinity, okay, e to the x is going to grow way bigger than ln of x. We just did it here. E to the x grows the fastest, ln grows the slowest. So this is going to get really, I'm going to say more huge, divided by slowly. So the numerator is going to keep getting bigger and bigger and bigger, and it's going to approach infinity. Last but not least, this example problem here, well, again, I told you e to the x is going to grow way faster than any polynomial. Therefore, this is going to get huge, divided by, well, more huge. Therefore, if the denominator gets bigger than the numerator, it's going to approach 0. Okay, so I know it's going to be 1 and I and the triple I. So it's going to be E. Okay, let's go ahead and look at another example problem here. Well, the limit as x approaches infinity, well, it's in factored form and I have to focus on the biggest degree factor. Well, I'll multiply 5x times negative 2x. I get negative 10x squared divided by, and what's 2x times x? We're going to get 2x squared. The x squared cancels out and we're left with negative 5. Therefore, A is the correct answer. Okay, this problem here says as x approaches 0, okay, well, if I plug in 0, just thinking about it very quickly, well, I'm going to get 4 times 0 plus 5 times 0, 0 plus 0 is 0, and I get that on the denominator. So first thing I have to do is let's go ahead and factor out an x to the 5th power, okay? So I'm going to get x to the 5th, and over here I'm going to get 8. Well, this has to be x to the 4th, right? Because 5 plus 4 gives me 9 plus 5 all divided by, well, x to the 5th. And this is going to give me 4x, 4, 5, 6, 7, 8, so to the 3rd, okay, plus 5. Well, look, these cancel out. Okay, so I'm going to be left with, I'll write it over here, the limit as x approaches 0 of 8x to the 4th plus 5 divided by 4x, all right, to the 3rd plus 5. Well, we're not asking for the end behavior because I'm asking you for an actual value to just plug in 0. Now that it's fully factored, okay, now I can just plug in 0 into my equation. And we're going to get 8 times 0 to the 4th plus 5, all divided by 4 times 0 to the 3rd plus 5. Well, I'm going to get 0 plus 5 over 0 plus 5, and I get 5 over 5, which is 1. So my C is going to be the correct answer, which is 1. This piecewise function here, all right? And so in order to do a problem like this, okay, well, you don't even really need to, I would say, to have to graph this, right? But let's just go ahead and factor the numerator. Well, we're going to get the limit as x approaches 3, and I'll have x, well, I think it's x minus 3 and x minus 4, because negative 3 plus negative 4 gives me the negative 7, and the multiply to give you a positive 12, all divided by x minus 3. Well, you'll notice these cancel out, and so we're just left with x minus 4. So that means, okay, well, my y-intercept is here, and I'm going to get something that looks like this. It's just a graph that looks like this, but at 3, there's a hole. Okay, that means at 3, there's a hole there. Okay, and it's going to look something like that. Okay, and that's how we could graph these. Okay, I just want to really pronounce the fact that at 3 there is a hole there. Okay, and now we can officially plug in 3. Now that we got that canceled out, we plug in the 3 and we get 3 minus 4, which is negative 1, which makes sense because this is negative 1, my y value. Okay, down over here, well, let's do the same thing. I'm going to get x plus 3, and down below I'm going to get x looks to be like plus 3 and x minus 1. Well, this cancels out, and I get 1 over x minus 1. I'll go ahead and write it over here. All right, and now I just need to plug in negative 3 into my function. So I'm going to get 1 over negative 3 minus 1. I get 1 divided by negative 4th. So at negative 3, we have negative 1/4, which is right there. But because we had to cancel out those terms, that tells us that we do indeed have, okay, a hole right there. Perfect. All right. Now, if you wanted to graph this, you could go ahead and graph the function, but we do know there's a hole at this spot right here. All right. We also know that there is no x-intercept, and we also know that if we were to take the horizontal asymptote as the limit as x approaches infinity of 1 over x, we get 0. And so I know it should probably do something, right? Something where over here it should approach it like that there, and probably do the same thing over here. I don't know. I'm thinking something like this here. Okay, something like that, and it should look something to that extent, or something that looks like this. Okay, and it gets closer to 0, and then vice versa. I don't know, something like that, right? But again, these are not perfect. You don't have to really graph them if you don't want to. The biggest thing for us is basically just knowing where the hole is located at. Okay, let's look at this problem here. Well, very similar to other problems that we've done. This is in factored form, so we need to go ahead and just kind of distribute things out. And we get x minus 3, x minus 3. Okay, well, I need to look at the highest degree on the numerator. So this is going to give me 3x squared divided by, and x times x is x squared. Well, these cancel and I just get 3. So y is equal to 3 is my answer. I'll go ahead and circle that in there. Okay. All right, this is a little bit of review. We've already kind of done a problem like this together many times, hopefully. And so this is just making sense. Well, it says, does the limit from the left and the right, are they equal to each other? Well, the limit from the left of 3, so 3 is right here, and from the left, it approaches, okay, 1. And the limit from the right approaches 3. Well, that definitely does not equal to each other, so this is false. because they don't give you the same value. Okay, let's look at this one here. The limit as we approach -1. Well, that's saying as we approach -1 from the left and from the right, because it doesn't have the plus or the minus there. So we have to take both the left and the right into consideration. So from the left, we get 3. Maybe I'll just write down over here 3. And from the right, we get 3. Perfect. So because the left and the right give you the same y value, then the limit, the overall limit as x approaches -1 from the left and from the right, we get 3. Now it's asking, well, what is f of -1? Well, at -1, we do have a solid dot there. So that is in fact 3. We can say that's true. Okay, well, the limit as x approaches 2, is that equal to f of 2? Well, when we approach 2, again, we are saying that we need to take into consideration the left and the right. So from the left, we get -1, and from the right, we get -1. So the limit as the overall limit is -1 here. Well, f of 2 is, well, it's not -1 because there's a hole there. The circled in dot is right there, which is 2. So this is actually 2. Well, these do not equal each other, so we could say this is false. So this is the only one that is true. All right. Pretty standard. Okay, last but not least, well, here's this problem. And again, we've done many problems like this before, so hopefully you're starting to feel pretty confident in these, right? We want to find the horizontal asymptote, so that's the end behavior. Okay, well, look at this problem here, the limit as x approaches infinity of cosine of 4x divided by 2x. Well, we showed on the other problem, cosine oscillates between 1 and -1. So the y values really, as we approach infinity, are just going up and down. It's wave-like. So as we plug infinity into the denominator is going to get way bigger than the numerator. Therefore, this is going to approach 0. So y is equal to 0 for a, which is not -2, so we can cancel that out. Over here, well, the limit as x approaches infinity, okay, well, these cancel out, and we're just going to be left with 10 divided by -5, which is -2, because 10 divided by 5 is 2, but we still have a negative. Well, hello, that is one of the answers, because that's what it was asking for right over here. All right, let's go ahead and let's close this one down, and I'm just going to change colors now just for the fun of it. Okay. All right, well, the limit as x approaches infinity, well, we focus on the highest degree, which is x to the 1000 divided by 3 to the x. Well, again, I have to tell you, okay, just so you remember, well, any exponential function is going to grow way more huge than any polynomial equation. So this is going to be way more huge. And since the denominator gets way more huge, okay, this is going to approach 0. Okay. Okay, over here, well, we have to be careful because it's in factored form, so we need to distribute it out. Okay, well, this is going to give me 10x squared divided by -2x squared. These cancels out, and we get -5. Shucks, that doesn't work either. All right, well, let's go ahead. And let's look at this one here. Oh, well, look, we have e to the x both on the same numerator and denominator. Just like we do with factors, we have the exact same thing on top and bottom. Okay, so these cancels out, and we are left with -2. This is nice. Nice, that's really, really cool. Okay, let's look at this problem here. All right, well, we have 50x squared over -100x squared. These cancels out, and I'm left with -1/2. 50 divided by 100, right, but you have $50 out of 100. That's half of the amount, so -1/2. That's not -2. So the only ones, okay, that we can conclude worked was E, okay, and B. These were the only, here we go. These were the only ones, all right? That's it for that set there. Thank you very much.